Welcome back. In this video we're going to cover one of the most important concepts, and this is dynamic memory allocation, or memory allocation on the heap rather than the stack. So this allows us to create memory at runtime rather than at compile time. And we'll also look at some other things like deallocation. So the biggest and most important thing to understand is going to be malloc. And then from there, you can learn the other parts, which are calloc, realloc, and free. Okay? If you understand malloc, these will make a lot more sense. And so we want to focus on malloc to start with. We'll look at free as well. And then from there, we'll understand memory allocation. So first things first, malloc is a function, and it stands for memory allocation. Now, with our programs, we've been including regularly standard I/O, but now we need to include another header, which is going to be standard lib. Okay. We need this because it includes malloc. From there, I'm going to create a main function, and down the bottom of this, I'll just have my return 0. Now, what I'm going to do is I'm going to create a pointer. Okay, so this shouldn't be anything new to you, and I'll call it PTR. On the right-hand side is going to be something very, very different, and we will have a look at this in detail. Malloc, size of short. Okay, so right here, what we are doing is we are basically dynamically allocating memory for one short at runtime. Now, this isn't a very good practical example because if we just needed one little bit of data, usually the heap would be better. I mean, the stack would be better, but it's a good example to start with. So, what does all of this right-hand side have to say? So, size of short tells me 2 bytes. Okay. Memory allocation tells me I would like 2 bytes of memory. Okay. And that's what the function is asking for. Now, the short star here is a typecast, and this typecast should be the pointer type that would point to the type that you're trying to create. Now, this isn't entirely necessary, but it will generate warnings if you are storing it in the wrong spot. So for example, if you had an int pointer here or something, it would give you a warning. So it's a good idea to include this while you're learning. Now, what does this function return? This function returns the address, or the starting address of the memory allocated. Okay. And we go and store that memory. Okay. Now, I'm going to draw the box and pointer diagram of this because it's important to understand that this memory is not on the heap, and so it's not within any scope. So here we've got our main function. Okay. And then over here we've got our heap. And on the heap, I've allocated 2 bytes. Okay. And these 2 bytes, I'll draw the full box and pointer diagram, is a short. And over in main, we've got a single pointer. Okay, it's called PTR, and its type is short star. Now, with this, that pointer points to the memory address of this memory here, because we get the starting memory address and we know a pointer points to a memory address, or it points to a variable. It stores the memory address. Now, from here, you'll also notice something that's very different with our box and pointer diagram. This memory has no name. So sometimes I like to refer to dynamic memory as nameless memory because we cannot refer to it by its name. Okay, so unlike the variables that you've been creating before, where you could say A, B, temperature, all of these different variable names, you could refer to them. However, here you cannot refer to them by name. So how do we access them? We access them through our pointer. So we can do things like dereference PTR and store 4 in there. Okay, and that'll just put a 4 in there. If you want to get memory out of there, so let's say I want to store a short, I'll call it A, and dereference that and grab the value. Well, we create the variable A, okay, it's type short, and we get that value 4. Okay, so we have to access this heap memory through a pointer. Now, this is where you need to be careful. So let's say instead in this program, I change this around a little bit. Okay, I'm going to get rid of all this. And what I'm going to do is I'm going to add an if statement. Okay, and the reason I'm adding an if statement is to limit scope. Okay, so let's just move that down a little bit. And I'll indent it just slightly. And we'll grab an if statement. So in my if statement, I'm just going to ask the question, if 4 is greater than 2, then we're going to allocate this memory. Okay? So we start our code, we come down, we get to this if statement, is 4 greater than 2? Yes. We get within this scope, okay, so remember this scope's within inside of main, okay, and then I allocate some memory on the heap, okay, so this is short, okay, I don't know what's in there yet, and I create this pointer called PTR, and it's of type short star. Hopefully you can see that star, and it's pointing to this memory. Now, because it's within this scope, as soon as I leave this scope, so I reach here, this variable's gone. Okay, because it's on the stack, it's gone. Now, the problem here is that I've lost any reference to this memory, and now I can't access it. Okay, so you have to be really careful not to lose your pointer that points to your dynamic memory, or you've lost your memory. Okay, and this can be really bad because this could be important information. So you need to make sure that your pointers, you've still got access to them when you need them to access this heap memory. Now, the next thing is that with the memory, okay, so let's get rid of this. Let's get rid of that. And let's put this back. Now, with the memory that we've got on our stack, when we leave scope, it automatically deallocates it, so we don't have access to it. However, with the heap, it just hangs around. And usually that's not a good thing. we want to maintain deallocation and allocation where necessary. So if we've got a huge amount of data on the heap, we're going to slowly run out of memory. And so when we don't need it anymore, we need to deallocate it. Now, how do you deallocate memory? Basically, you type free, and then you pass the pointer that's pointing to it. Okay, so PTR. And that will free this memory up. Okay? Now, you have to be careful not to use that pointer and dereference anything now, or else your program will crash because it's not pointing to anything valid anymore. Okay, so just be careful after you free that you either reuse it or you change scope so you get rid of it. Okay. Now, while doing all this, we have been a little bit unsafe because what if there isn't enough memory on the heap? Which is a rare case, but it can happen. And if that happens, our program is pretty much not worth running. Okay, if we don't have enough memory to run the program, then we need to kill the program. Okay, so we're going to have a look at that. I'm going to move that a little bit and actually change that. I need a bit more room. So I'll move this down. Cool. All right. So what I'm going to do is I'm going to put an if statement after this. Okay? To see if the allocation actually worked. So I'm going to write if PTR equals null, then I might do a printf, let's say malloc failed. I might put a bit more detail depending on the circumstance, but I'll let the user know that this is a critical error. And then I'm going to do something that we haven't done before. And you need to be careful when doing this, and you should only use it for critical situations. Okay? So what we're going to do is we're going to type exit. In brackets, we're going to write exit. I'll move main out of the way. Exit fail. Yeah. Okay. Now, the reason that we use this function here is because when we have a critical error, okay, so something's gone wrong with the computer, we cannot do anything more. Okay, the program has finished. We cannot do any more. We need to let Unix or our operating system know, or our user to know, that we exited on a bad situation. It didn't finish successfully. Usually we want to finish successfully. We get to the end of the program, okay? But this is the case where we cannot, no matter what, finish successfully. This is not a case where you're picking up an invalid user's input, okay? An invalid user's input, the program is still running as it's meant to, and so it still should return 0 at the end. But for something that's out of our hands and that we can't deal with, this is when you need this exit, okay? So only use this where it is appropriate. Now, why did I compare it with null? Well, if malloc fails, it basically returns the null pointer, okay? All right, so in this video, we had a look at malloc, we had a look at free, we had a look at maintaining our pointer to our memory and being careful that we don't lose it. We also looked at how to ensure that if that malloc was successful and what to do if it fails. Okay. In the next video, we'll look at using malloc to store more than one bit of data, which is usually the case. Remember that the heap is really large, and so we usually are trying to store large amounts of data on the heap. So we'll have a look at that in the next video. Thank you.